Thank you. So, I think that I will speak English because there are guys that don't know Russian at all, and I just thought that it would be good for them to understand. Okay. So, if you were expecting some business promo of Svetla Systems, I'm gonna to disappoint you because this will be a developer speech and developer talk about the patterns. Okay, do you hear me? So let's start. My talk is named Rails plus GoF patterns equals question mark. So what's the big deal here? The big deal here is that the patterns are very okay. So the big deal here is that patterns are very discussable topic over the developers networks, and so developers divide into two parts: those who love patterns and those who says that this is crap. So this is what we don't want to use. And I think that you know that there are such a book like Design Patterns, Object-Oriented Software, and this is translated into Russian like приемы объектно-ориентированного программирования. You know that there is such a book like Design Patterns in Ruby, but there is no such a book like Design Patterns in Rails. So, and I was taught when I was studying in the high school, I was taught to use not OOP, but I was taught to use the patterns. So when I started using Rails, I knew the patterns, and I actually thought that this is just common practices for designing applications. So I didn't even know that they have some special name, like pattern. I just used them because I saw that this is good. The only thing that I didn't I was not good enough in this was web development, and so this led me to some mistakes that I will show you, and that led me to some real world experience that I will share with you, which I got with using the patterns in Ruby on Rails. So design patterns. Who knows what is that? Okay. Who doesn't know and would like to know? Okay. So the design patterns, this was such a book written in 1994. There was 4 authors of that. You saw this: Gamma, Helm, Johnson, Lycides, and so they are named like gang of 4. And this is very discussable topic, and this book is now sold in 13 languages in 500,000 of copies. So this is very popular book, and after that there were too many, many patterns of different other authors like Martin Fowler and so on. So but they all started with this first book, and so this gang of 4, they introduced 23 reusable patterns. They divided them into 3 parts: the structural, creational, and behavioral. So pattern itself is not like it's just a common practice. So you don't need to use it as it said in the book. You just need to get the idea and to implement in your real world project just as you need it, because it's not like a silver bullet, you know. It's just the practice that you may follow or you may not, and you decide. So the structural patterns is the set of patterns that allow you to structure your data. And there are like 7 structural patterns. So they are very good fitting into Rails because this is static object constructions. Next is creational patterns. creational patterns, there are only 5, and they are also good to have they are also good implemented in Ruby on Rails because it's just the classes, the patterns that create object. They help you to create object. And the last one, the biggest one, 11 patterns, which are called behavioral patterns. And these are the most, like, these are the worst using in Rails just because these patterns usually used for the UI, the user interface interaction with the application. So all these patterns, they are mainly used for keeping the UI in some static applications up to date. So they support some commands like undo, like just keeping different parts of UI together and so on. But you can see that there is some one pattern observer that is actually implemented in the core system of Rails, but it's not used for the UI. And so I was developing in Rails maybe half a year, and I always dreamt about some project where I would implement all the stuff that I knew, but actually I was not using it. And then this project came, and the project was very cool, was very big. It was a project for IP telephony, and so we needed to build a site which would show the settings of IP telephone service subscribers, and this site should have shown all the possibilities for the user. So calling logs, the forwarding settings, the privacy settings, the shop for ordering some products, some bundles, some features, some subscriptions, and so stuff. And the main problem was that this service, we needed to talk to 3 different WSDL services, to many XML services, and we had many, so here is 5 foreign databases which just stored, like one database was storing the calling logs, another database was storing the data for contact info, this third database was storing the blacklists. And the thing was that also that different UI parts, they needed to talk to different services. And so, and we needed also the local database because, so this was the requirement of this project. And so you can see just sample diagram of what we had to implement. Okay. And what challenges we had in the project? The challenges that we faced are very simple. The first one is that the UI of our site, of our service is one, and the data that we can get from different services is very different. So it doesn't fit at all into our user interface. That's the problem. Next one is that we need to pull everything into database. So even the WSDL calls, which are sending just you some messages info, for example, the length of message and the URL where you can download the message, still we need to store it into the database because there was the requirement that several sessions should be like kept when several browsers should show the same info if they have logged in the same user. Okay, so we needed to convert even WSDL to the database, to some cache. And the third one is Rails. You all know what Rails is good at and what Rails is bad at. So we had to deal with all that. And just some details about the structure of our application and the structure that we could receive from the server is that we were building an application which was actually very single. Like we've been able to create a single system of it. It has been a single system, and the services that we had to use, they were not built as single systems. So we had to call one service to get the session ID, another service to get customer PK, and the third service to get the actual info. So this was like the data structure of our project. It was like ideal data structure. It was the initial data structure. So we started with that, but we broke up with that because so we did everything as the textbook says. So if some field belongs to account, then there should be account object. If some field belongs to device or number or inbox, it should be inside of the inbox object. And so you can see, so actually if you have dreamt some day about building your IP telephony business, this is the business model for your business, okay? You can go away and build it because this is ideal. But the real world was that we didn't have any such structure. We had different calls, which one call could return us users, devices, numbers, another one returned services, another one returned addresses, and you can see that many domain objects are not present on this slide. You see, it's completely different. And it's not different only in data structure, because as I said, when we have UI, and you can see that different parts of the UI, they have to be taken from different services. This is about the blacklists, and you can imagine what happens on the dashboard. Okay, so on the dashboard we have to talk to 7 different services to collect all needed data. And so when I heard about all that, I started to think in a design pattern way. So which design patterns we tried to use here, and what were the results? The first one is facade. You know what is facade? You know what is facade pattern? Okay. Do I need to explain what is that? Okay. So facade pattern is just some abstract class that makes your system divided into 2 subsystems. What does it mean? So if you have 50 active record objects, models, and if you have 50 remote services, you can connect them many to many, and you will have 2,000 of connections, okay? And you can use single class like facade that will just connect. So the active record models will connect to facade, and facade will send the needed requests to the server. Okay, so it's like in complete code, it's called complex, like less complexity. So this is the UML diagram of facade. You can see that. Do you understand what is there? Facade is in the center, and there are some different clients, and facade just he receives do something from different packages, and depending on the parameters or arguments, he just sends the request to different clients. Pretty simple. And facade is always so like there cannot be 2 facades in the system. So a facade is usually implementing the Singleton pattern. What is Singleton? Singleton is very simple. Singleton hides the constructor into private field, and he gives you interface of getting instance of it. Just a public class method, just one method. And when there is no such class, it instantiates it. When there is, it just returns. Okay, very simple. Builder. We wanted to use builder because we had to build many objects, and we had to build many objects from XML, WSDL, and very many other stuff. So builder is just like a class which takes like for himself the building of your objects. So it's just there are different objects. You can see the product rectangle. So there are different products, and for each product there are different builders. And this is very helpful because you don't store all the code in one class. You just use different builders. The next one was Flyweight. Flyweight is actually such pattern when it's used when you have to show, for example, symbols in one string, but different symbols are used several times there. So you have just one pool of flyweights in the memory, and you just keep only one instance of each object in the memory, and you just show them using different approaches. Okay, so this is flyweight diagram. It's very hard to understand. The last one is Proxy, and this is very simple because Proxy is just the same class as the real subject, but the only thing is that it knows some fields, like you may say it caches some fields, and it returns it for the client demand. And if proxy object does not know something, it delegates to the real subject, and the real subject returns the result from himself. Okay, so this is the patterns which we wanted to use. Actually, there are many possibilities for other patterns also, but they are not yet implemented. Starting with facade, so we started with facade and we call it connection adapter. Okay. Of course, as I said, it should be singleton, and what we did, we created the class method instance, we created the class variable instance, and we hide the initializer into private field. What was the result? Who knows what was the result? Raise your hands. Okay. It was a very bad result, because you should not use the class variables in Rails, because the Ruby shares the class variables between all its processes, and when we created the adapter with class variable, just every user who logged into our system, he got the different data. So he just got the data for other people. Okay. Another problem was that we had to send when a user interacted somehow on our site, we needed to send the XML or WSDL calls back. So we needed to save the same objects on the remote servers. And here came another problem, that if you have device associated with some other objects and you change the associated objects, you can't send the device into generator. So because when you take settings from device again in the generator, they are loaded from the database, and your changes that you made in your controller, for example, they go nowhere. So it was good. It was good ability to use the Flyweight, and it is now implemented as identity map plugin for Ruby for Rails 3. You told about it yesterday. and the identity map is really good at keeping your objects single in the memory, but it is bad because you need to totally change your approach to the active record associations. So they are very different. Next one was Builder. And so using Builder, you remember that we had the ideal structure. Yeah? Okay. So, yeah. So we tried to build the ideal structure of this structure. And actually, we could not because, so eventually we just broke up with this approach, and we use Builder just to build our structure of our application as it is present in XML, as it is present as in WSDL, as it is present. So we are not creating a new structure, we just take the XML, for example, and we build the same objects in our local database. Because dealing with these very many dependencies, which field from which service we should take to build the whole object in our memory is just very different. And finally, we came to this design, which has user session in its root, and user session is the main object in Ruby on Rails, which you should use as a singleton and as a facade. Because this user session exists always, it has associations with all other objects, and it is well taken from the controller. And for the last one, we used here the proxy pattern because it gave us possibility to take only needed fields from some XMLs. And just for the end, I can show you that user session came out to be the best approach here. So we totally removed the connection adapter class, and we just created several extensions for the association collection, association proxy, and other active record classes, which allows us to lazy load the needed information and to build the needed objects on demand. So this is for building. This is for some again, so delegation like proxy, and just user session methods which act like adapters to these different interfaces. So the results was that user session is the only singleton and facade in Rails. So if you have the structure that is different from the structure that you would like to have, don't waste your time and just build what there is present, because it will result in nothing. The identity map allows you to keep one object in the memory, and the lazy loading is cool because you can load the objects when you need it. Just you need to implement it in the best way. Okay, so this is the end. My friend, you can give me your questions.
Hi, my name is Maxim. Why don't you decide to use data mapper?
Okay, it's very easy. Because I didn't know data mapper. Oh.
Okay.
Okay. What would it give me? Okay. Okay, questions? Может, по-русски рассказать то же самое второй раз? Guys, I can encourage you to learn patterns after all, because they are very good. Just to know about them. I just when I was going today on the conference, I remembered that Steve has written some weeks ago about decorator pattern in his blog, and so so Rails is a hash of, so it's like a set of classes, but still you are able to use the approaches that are present already in the world. So don't close your eyes into what is happening in the outer world. The Rails is not a silver bullet. So use patterns, use Erlang, use CoffeeScript and JavaScript, use Node.js. Just keep your eyes wide open and see what possibilities you have for building your software. So Rails is good, but Rails is good when you like use it good, and use other tools for other problems. Okay.
Okay, thank you, Marat. It was a very nice talk. We have a half an hour till our next speaker, Pat Allen, who will speak how to craft gems.